Welcome, everyone, to the Intel Builders webinar program. Thank you for taking the time to join us today for our presentation titled Creating Platform-Agnostic Packages with Habitat. Before we get started, I want to point out some of the features of the BrightTalk tool that may improve your experience. There's a questions tab below your viewer. I encourage our live audience to please ask questions at any time. Our presenter will hold answering them until the end of the presentation. Below your viewing screen, you'll also find an attachments tab with additional documentation and reference material, including a number of websites and documents mentioned in this presentation. Finally, at the end of the presentation, please take the time to provide feedback using the rating tab. We value your thoughts and will use the information to improve our future webinars. Intel Builders webinar series takes place live every week, so check the channel to see what is upcoming and access our growing library of recorded content. Today, we are pleased to welcome Nell Shamrell-Harrington. Nell is a senior software development engineer at Chef and core maintainer of the supermarket and habitat projects. She also sits on the advisory board for the University of Washington certificates in Ruby programming and DevOps. She specializes in Chef, Ruby, Rails, Rust, regular expressions, and test-driven development, and has traveled the world speaking on these topics. Prior to entering the world of software development, she studied and worked in the field of theater. Welcome, Nell, and thank you for taking the time to join us today.
Thank you so much for having me. It's fantastic to be here. Well, good morning or good afternoon or whatever is appropriate wherever you are. Thanks for tuning in with me, and let's go ahead and get started. I'd like to start today with a question, and that is, what if you could build software once and run it anywhere? Whether it's in a bare metal server, whether it's a virtual machine, or in a container. What if you could move a legacy application into the cloud without having to rewrite it? What if you could empower your applications to recover from failure on their own without needing a central manager or orchestrator? Well, I have news for you today, and it's good news. You can do all of these things today with Habitat, which is a new open source technology from Chef. Habitat goes beyond infrastructure automation, beyond cloud automation, and into the world of application automation. Now, we'll go deeper into what that means in just a little bit, but first, let's briefly cover who I am. As you heard, I'm Nell Shamrell-Harrington. I'm a senior engineer at Chef, a core maintainer of the Habitat open source project. You can hear me on the Food Fight Show podcast, where we talk about dev, ops, Chef, Habitat, and everything in between. Feel free to tweet at me at Nell Shamrell or email me at nshamrell@chef.io. And I will put these details back up at the end of this presentation. Now, the reason I'm here to speak today, the reason I hope you're tuning in to hear me, is that Habitat is 100% open source. We distribute it under an Apache license, and if you want to check out all the repos that make up this project, head on over to github.com/habitat-sh. Now, before we go into what exactly Habitat is, it's crucial to understand the why. Why would we create a new kind of automation? Why would we create this tool in the first place when so many tools are already out there? And the answer to this is pretty simple. It's because building and running software is still very painful. You're tied to particular runtimes and environments. You have to use one runtime for a Java application and another for a Ruby application. You need different packages for different flavors of Linux. You need a Yum package for Red Hat, a Deb package for Debian flavored Linux distributions, and you need different packages for bare metal/virtual machines versus what you need for containers. Now, Habitat seeks to alleviate this pain by building what we call modern applications. And what I mean by a modern application is an application that is immutable, that is agnostic to running environments, that reduces complexity when you automate it rather than increasing complexity, and that enables scaling both up and down. So that's briefly the why of Habitat. Now let's cover just a little bit about what Habitat is. Briefly, Habitat is a new technology to build, deploy, and manage applications that can run anywhere, from your traditional data centers to your containerized microservices. This is because in Habitat, the application itself is the unit of automation. The application package we create with Habitat contains everything needed to deploy, run, and maintain the application. So that's a bit of the what of Habitat, and it probably sounds good, but let's talk about how exactly this works in the real world. And let's start with how you would package an application with Habitat. Packaging an application with Habitat starts with the user. This is you at your workstation. It doesn't matter whether it's Windows, Mac, Linux, Habitat works on all of those. And on your workstation, you write a plan. This contains everything needed to deploy your application and how to set it up when it's deployed and run it. So for Linux systems, you would write this plan in Bash. Soon we will also allow you to write plans for Windows, and those will be written in PowerShell. There's some functionality for that right now, but it's still pretty early, so I always say that's coming soon. And with that plan, you create an artifact. And this artifact contains both the compiled application itself and everything needed to run it. So this artifact is signed with a key, and we'll go into what that key is used for in just a moment. But then the last step is optionally, you can upload it to the public depot. This is where you can find Habitat packages by developers all over the world. And if you'd like to check out this depot, head on over to app.habitat.sh or habitat.sh and click on the depot link, and you'll be brought to the public depot where you can search for packages for any kind of technology you're looking for. So in this case, we're searching for a node package on the public depot, and you can see there's lots of options available, and we'll use one of these in a demo in just a little bit. Now, when it comes time to run the application with Habitat, if your package is on the public depot, again, that's optional, you then pull that artifact from the depot onto wherever you want to run it. Again, whether it's bare metal, virtual machine, or container. Now, if you're not using the depot, you can also put that artifact wherever you want to run it using SCP, FTP, whatever sort of file transfer protocol that you want to use. Now, when it comes time to running an application with Habitat, this is kind of what it looks like, and we'll see a running example of this in just a moment. But here we have a virtual machine that's running a Habitat package as a service under the Habitat supervisor. The supervisor is what actually runs the application. Now, a cool thing about it is no matter where you're running your Habitat package, there is a standard REST API, which is really useful when you have something like a load balancer that needs to get information in and out of that application. The process is the same regardless of whether it's a VM, container, bare metal, whatever is most appropriate for you. Now, the real power of the supervisor, the real power of running an application with Habitat, you see that most when you have multiple instances of that application running. So in this case, we have 4 virtual machines all running the same package under the supervisor. What the supervisors of these do is they form a ring where they can communicate with each other and self-organize. And all this communication is done over an encrypted gossip protocol. And in a moment, we'll see a demo of them organizing into a leader-follower topology for a database cluster. Now, I want to add that Habitat has many different parts, many of which are still in development, including the builder service, which if you watch the Chef Comp keynote, you might have heard about. Now, what I want to highlight the most in this particular webinar is what you can do with Habitat today. And part of the reason for that is so that together we can shape where it goes in the future. As I said before, this is an open source technology. Where it goes is largely going to be shaped by our community of users and contributors. So what we will discuss today is first we will talk about the Habitat supervisor and see a demo of that running. That's what actually runs your application. Then we'll go into the Habitat packaging format. This is what you make on your workstation with your application in it and everything needed to deploy it. And then we'll also cover Habitat with containers. Now, though Habitat does work without containers, and we'll see examples of that, I think it really shines the most when you use it with containers. I mean, I'm often asked when I talk about Habitat in the public, why are you trying to create a replacement for Docker or for Kubernetes? And the answer is we're really not. Habitat complements tools like this and makes them work even better, and we'll see some demos of that as well. But for now, let's focus on the Habitat Supervisor. The Habitat Supervisor is what actually runs your application, and it has a few different roles. The first one is to act as a process manager. This means it starts up and monitors the package. Then it also receives and implements configuration changes. Any application that's running more than a few hours likely is going to have configuration changes made to it. So the process manager is what allows you to receive and implement those configuration changes. And finally, the process manager runs services. And what I mean by a service is it's a Habitat package running under a supervisor. And the simplest example of this is one supervisor running one service. And again, looking at this visually, it would look a little bit like this. Here we've got a virtual machine with a supervisor that's running a service. Now it's nice to see pretty graphics of it, but let's look at an actual demo of this. And I'm going to switch to sharing my screen and then pull up my demo. Let's go to full screen. So in this demo, I'm in an application called My Tutorial App. And at this point, I've already packaged up my application into the Habitat artifact. That's in the heart format. And we'll see exactly how we do that in a later demo. Now, this is a Node.js application. And if I want to run this, I will go ahead and grab that most recent build. And then I'm going to SCP that package up to an Azure VM. And all I've done at this point is created an Ubuntu Azure virtual machine. I have installed nothing else on it. So I'm going to upload that up from my local workstation to that virtual machine, and I SSH into that virtual machine. Let's go into it using its public IP address. And then when I list everything in the home directory, I see that my package to install is in there. Now, if I want to install this package and run it, first thing I'm going to do is install Habitat, which I can do through a curl command. That's available in the Habitat GitHub repo as well as the website. And once I do that, once I've installed Habitat, I'm next going to install my package. So I do sudo hab install, pass it that package name. And I've sped this up just a little bit, but it's going to go ahead and install it. And next thing I need to do is there's two steps needed for me to run that package. And the first is I need a hab group on my Ubuntu system. So I'm going to go ahead and add that. And once that's complete, then I need to add in a hab user and add that user to that group. This is what's required for Habitat to run my Habitat service, to run my application. So I start it running sudo hab start, and then I can see the service is running on port 8080 of my virtual machine. So if I want to see how that looks, I head on over to the IP address of my VM, go to port 8080, and there is my running application. So that's all it took to get a Node application running on a VM. And again, I did nothing to that VM before SCPing the package up to it and installing it. So that's how easy it is to get a running application with Habitat. Now let's go ahead and exit out of here, and I'm going to put my slides back on. And all right, so that was a demo of running one package with the supervisor. And that's the simplest example. But when you get beyond one supervisor or one service, you need what's called a supervisor ring. So let's look at this visually before we look at a demo of it. Let's say I have a virtual machine. I'm running a MySQL package on it that's created with Habitat, and it's running that MySQL service under the supervisor. And one virtual machine works okay for my application in its early days, but eventually I want a cluster. So I do that by spinning up two more virtual machines, also running MySQL. And then because they're signed with the same key, we can peer them together and they will find each other and be able to communicate with each other over that encrypted gossip protocol. Now, the really neat stuff is when I start the supervisor, I tell it I want it to be in a leader-follower topology. That's common for database clusters. Now, once they become aware of each other, once there's 3 of them running and they're paired with each other and aware of each other, on their own, they will hold an election using a built-in election algorithm. And this is without any human intervention beyond starting the services. So once they do that, they're going to hold an election. And let's say this one here at the top wins the election, so it becomes the leader. And then these 2 here on the bottom will become the followers. So the leader will receive all the write requests to this database cluster, and the followers will receive all the read requests. Now, let's say something bad happens. It can be anything, but something happens and our leader goes offline. The other 2 are going to realize they cannot communicate with that supervisor. They cannot communicate with the leader, so they will automatically remove it from the ring. Now we have a dilemma. We now have 2 followers without a leader, and what we've done when we've set it up with a leader-follower topology is they've made a promise that they will always be in that topology. So when they realize they don't have a leader, they're going to go ahead and elect a leader again. Again, they do this on their own without any outside intervention. And let's say this one over here on the left receives the write request, and this one over here on the right becomes the follower, and it receives the read request. So again, they do this all on their own without the need for a central orchestrator. Now it's nice, again, nice to talk about it, nice to see pretty graphics, but let's look at an actual demo. I'm going to share my screen again, and let's pull that demo up. So in this demo, I'm running 3 AWS virtual machines, and up here on the top, move that out of the way, there we go. I start by running a sudo habstart core MySQL, and the MySQL package, I'm pulling that from the public depot. It's under the core origin. We'll go over what the origin means in just a moment, but for now, think of it as a namespace for packages on the depot. And I tell it I want it to run in the leader-follower topology, and I assign it to the group production. So once I start it, you can see it says there's an election in progress, but they don't have a quorum. In order to have a quorum to run that first election, they need at least 3 supervisors in that ring. So the next thing I do is start it up on the second one, and this time I peer it with the first one using that IP address. And again, it still doesn't have a quorum, so we go over here to the third one. I start it up, again, peer it, and this time they hold the election. And we can see that the election winner is this ID. So this is an internal Habitat ID, and while it's useful to know someone's the leader, as it is right now, it's not very useful to tell us exactly which virtual machine is that leader. So in order to find that out, I'm going to head on over to my browser, and I go to the public IP of one of my virtual machines, port 9631/census. Let's move this out of the way so you can see that. There we go. And next thing I'm going to do is I'm going to search for that leader ID in my browser. In fact, let's up the text just a little bit. So I search for that leader ID, and that brings me to a little section about the members of the supervisor ring. And I can search for the leader ID, and then I can get the IP address of that leader, which in the case of AWS is the private IP address. So I can then match that private IP address to one of my virtual machines. I tend to just do this in the AWS console. And then I know that this one over here on the left is the leader. Now, let's say something bad happens. In this case, it's me. I manually shut down that service running on the leader. The other 2 are on their own going to realize they don't have a leader, so they hold a new election. That election's in progress, and that's the new leader, which corresponds to a different virtual machine. So again, they do all of this on their own, except for that initial setup. They can self-organize and re-self-organize when needed on their own. Now let's go back to my slides. There we go. All right, so what this demo illustrates is that in Habitat, when you have multiple components, Habitat assumes that failures will happen and that they are normal. We don't try to anticipate every single failure case beforehand because, frankly, we just can't. There's always something unforeseen that's going to potentially happen. So when a failure happens with one of the components, the healthy components will self-organize and reconverge. And again, there's no central manager or orchestrator. They do all of this on their own. Now, we just saw the leader-follower topology, which is one of the topologies you can use with Habitat. And the other one currently available is standalone. And in the standalone topology, we assume that every member of the supervisor ring is working as an individual that happens to be in communication with all of the others. Now, in addition to running that service, the supervisor also handles all the package updates. So when there's a new release available on the depot, we can pull that in, or we can manually load that new package up to wherever we want to deploy it. And it will deploy it according to a defined update strategy. Now, the only update strategy currently available is all at once. So that's whenever a new package becomes available or there's a configuration change, all the supervisors in that ring will update at once. Soon, you will be also be able to define a rollout strategy. And what the rollout strategy does is if you have a ring of, say, 4 supervisors, one will update, only after that one's complete will the next one update, and only after that one's complete will the next one update. So only one supervisor is updating at any given time. Now, we've seen how we can run packages with Habitat, but this begs the question, how does the supervisor get something to supervise? How do we create that package in the first place? Well, we do that using the Habitat packaging format. And we like to say it's in the heart format. This is because we heart you. Looks like the slide got a little bit warped there, but it's because we heart you. And these packages contain the application itself, along with everything needed to deploy and run the application. So all of that is contained in that heart format, and heart stands for Habitat Artifact. So again, good to talk about it, but let's see an actual demo. I'm going to share my screen again, and then look at my demo here. And in this case, I'm in the repo for that Node.js application that we deployed in the first demo. So in this case, I've got all my source code for my Node.js application in this source directory. And taking a look at that, let's just see how this package is made up. First file I have here is server.js. So let's go into here. All right, and I can see it's pulling a configuration file from a config.json file. It's getting a port, and it's doing something with that port. So that's the main file of my application, but let's briefly look at the other ones. So let's look at our config file. That's in our config directory, so config.json. And what this one does is it defines certain variables and the values for those variables. So in this case, I have a message variable that is hello world. That's the defined value for it, and port of 8080. So these will be used by my server.js. And finally, let's look at this last file, which is package.json. And this defines the metadata for my Node application. So the name is my tutorial app. It's distributed under the MIT license. And the thing I want to highlight is there's some dependencies. We're depending on another Node package called nconf. We need to pull that into our application in order for it to be able to run. So let's go ahead and exit out this. So that's the source code for my application. And let's go back up one directory. And let's take a look at the Habitat code. So in Habitat, I have my plan.sh file. And what I define in here, first we're going to define some metadata for my package. So my package origin is Nell Shamrell. That's the namespace for your application on the depot. And that's also how you define the keys that are used to sign and authenticate that application. So we've got that in there. And the next thing I need to add in is I need to add in some dependencies for my application. So in this case, I'm going to depend on another Habitat package, and that is Node under the core origin from the public depot. Then I need to export something. So in this case, I'm going to assign the port variable, which is defined elsewhere, or I'm going to the value of listening port, which I have defined in a separate configuration file. So then I use that to define which port is exposed when I'm running this in a Docker container. And the next thing I need to do, now that I define the metadata for my package, is I need to use callbacks. Callbacks define what the package does at certain life cycle points of the application. So the first thing I need to do is define how to build the package. And I do that using the do build callback, and this is written in Bash. This is a Linux application. And as you can see, I'm copying some things into other places, and then I'm running npm install, which will install that nconf module that we're dependent on. Now, after I define the do build callback, this is what we do to build the application. Next, I'm going to define what we do when we install this package on wherever we want to run it. So I define those in the do install callback. So in this case, I'm copying more things into places they need to be. I'm making a directory, and I'm copying the node modules to that directory. So let's go ahead, and now that we've defined how we build and install the package, let's take a look at how we would actually build it now that we've defined our plan. And we do that by entering what's called the Habitat Studio. The Hab Studio is a clean room to build your package in. It's a defined environment within your workstation, so you can build it, you can install it without having it affect the rest of your workstation. Now, if I want to build my package, once I enter the studio, all I need to do is run the command build. And once I do that, I've sped this up just a little bit for the sake of time. But it's going to go ahead and build it according to that plan, and I know that the build was successful when I see the message. I love when a plan.sh comes together. And now if we exit out the studio, let's go ahead and exit here, and look in my results directory. That's the directory that's created, if you don't already have it, to store the built packages for your application. I can see that I now have a freshly built package, the Nell Shamrell My Tutorial app, and that is a Heart package file. So that's how easy it is to build a package with Habitat. Now there's a couple more things we need to do to get this able to run. We need to define the behavior there, but this gives you an idea of the process of building a package with Habitat. If you want the full details, head on over to habitat.sh and check out our tutorials. All right, so let's exit out of here and go back to my slides. Oop, there we go. All right, and so we just saw a demo of creating a Linux package. And a few notes on this. As we just saw, Habitat plans use Bash for packages that will run on Linux, but you will soon also be able to create packages for Windows using PowerShell, and that is still in development right now. Now, along with creating Heart packages and running them with the Habitat Supervisor, you can also export them to other formats. And by far, the most popular format people export packages to is Docker container images. We do use Rocket container images as well. You can also export that to that, but Docker is by far the most popular. And that brings us to Habitat and containers. Now, getting artifacts to run anywhere is very difficult. That's not a new problem. We all know that. And containers were supposed to solve this problem, but there's still a lot of pain with their use. There's still a major learning cliff between using a container in development versus using it in production. Additionally, containers have a tendency to become black boxes. We don't always know what's in them. If you create a container image that has an entire operating system in it, but only use certain parts of that operating system, there's a good chance there might be a security vulnerability with a different part of that operating system that you wouldn't know is in there, or that you would forget was in there. So black boxes cause security issues. Part of the reason for this is that when we traditionally create containers, if you can call containers traditional at this point, I suppose, is we start with the entire operating system. Then we add in the libraries for that operating system, then the libraries for the application, then we only add in the application at the very end of creating that container image. Now, Habitat, by contrast, turns this workflow on its head. We start with the application first, those application libraries. So we define the application, we use that application to pull in the libraries that are needed for it, and then we only add in the absolute bare minimum operating system at the very end. This starts with just bin/sh, and then we pull in only the parts of the operating system that we actually need. So again, Habitat starts with the application, a minimal operating system comes later, And the application itself is what declares the dependencies, and the dependencies are resolved from the application. That means we only pull in what that application needs. And finally, we still have that exposed API for external services. We can still get information in and out of that application, even though it's running in a container, in the same way we would if it was running on a virtual machine or bare metal. So in summary, when you create a container image with Habitat, you know exactly what went into that container and exactly what is configurable about that container. And again, enough with the talking. Let's see an example of this in action. So again, I'm going to share my screen and then pull up the next demo. And I'm still in that same Node.js app. It's called My Tutorial App. And I've already built it at this point. Now if I want to export this heart package as a Docker image, all I need to do is enter the studio and run one command. And that is hab package export Docker. Then I give it the origin / the name of the application. So this will automatically create a Docker container image for me with everything needed to run that application in a container. And I sped it up a little bit for the sake of time. But now I've created my Docker container image. It just took that one command. And then let's go ahead and exit out of the studio. Exit. There we go. And now if I want to run this Docker container or run this Docker image, all I need to do is run sudo docker run. Tell it to run on port 8080. And then I pass it in the container image name, which is the container image name is my origin / the name of the application. So let's run that. I see that my Node.js application is running on port 8080. So let's go ahead and look at this in my browser. I'm running this one locally. So I go into my browser, go to localhost port 8080, and there's my running application. So that is how easy it is to go from having that heart package that's pretty straightforward to create, and then having a instantly deployable Docker image or Docker container image. So let's exit out of here and go back into the slides. Whoop, there we go. All right, so it's nice to create the Docker container image and have it running on your local workstation. But when it comes time to actually deploying it somewhere other than your workstation, you can deploy that container image using container scheduling services such as Kubernetes, Mesosphere, and Docker Swarm. And then you can also deploy that same container image using cloud-based container services like Azure Container Services or Amazon Container Services. Habitat doesn't seek to replace any of these. It's not a competitor to them. Rather, it complements them and makes working with containers even better. Now, as we wrap up, there's a few things I'd like you to take with you. And the first is the knowledge that you can build software once and run it almost anywhere. You can build a legacy application into the cloud without having to rewrite it. And you can empower your applications to recover from failure on their own without the need for a central orchestrator. You can do all of these things today with Habitat. The key thing to remember about Habitat is that Habitat is not infrastructure automation, it's not container automation, it's application automation. The application itself is the unit that we're automating. Now, if you'd like to get involved, and I hope that you do, head on over to habitat.sh/community, and you can get started from there. So again, I'm Nell Shamrell-Harrington. That is all my info, and thank you so much. And I'll now go to some questions. I'll go ahead and read the... Oh, go ahead.
We do have a few questions now. The first one is, do I need to write out a full plan each time, or are there some templates for common frameworks like Node.js or Rails?
The answer to that is you don't have to run out a full plan each time. There is scaffolding available. The two ones we have that are working best right now, that's actually the part of Habitat I'm focusing on at the moment, is we have scaffolding for Node.js applications, which means if it's a standard one, you don't need to write those callbacks. And then there's one for Ruby applications that can also be used with Rails. So yeah, head on over to habitat.sh to get some more information about those, or head on over to the, let me go back to the link for the community page. Let's go back just a bit. Head on over to there. We have a community Slack room, which all the core maintainers, including myself, are in. And we're there to answer questions or help you be successful with Habitat.
How is Habitat different from Chef?
That is a good question. With Chef, the focus of automation is on the infrastructure itself. Historically, Chef has not been great for actually deploying applications, though it's been fantastic for getting the infrastructure you need set up for it. Habitat focuses on the application itself and how you deploy it, and we don't focus as much on what the application is running on. Rather, we make it agnostic, so wherever it's running, it runs the same way. So that's a large overview of how Habitat is different from Chef. But in summary, Chef, the infrastructure is focused as the source of automation. In Habitat, we focus on the application itself.
Do I have to use the public depot, or can I have a private depot for my organization?
And that is the most common, excuse me, that is the most common question I generally get. And the answer is, although we do plan to have an on-premises private depot option in the future, right now our focus is on the public depot. However, we're currently working on allowing you to have private packages and private builds on the depot. So you can still build them on the public depot, but they're only visible to you. They're not visible to the general public. So that is our immediate focus, but an on-premises solution is one that we're going to be looking at a little bit later.
Thank you. That is all the questions we have for today. Excuse me, I would like to thank Nell for taking the time for this informative presentation, and I would like to thank our audience for joining us. I hope everybody has a great day. Thank you.
Thank you.